So when I look at this, I don't want to just stare at it, right? So one thing that I can start with is counting the number that are presently there, right? Because we just have to start experimenting. First thing I can do is count how many cubes are in the box, and a strategic way of doing that is breaking it down into layers and then labeling how many are there. So let's start with that. I want you to start on the bottom, and then you girls count and tell me how many are in each layer.
Okay, for the length, it will be 1, 2, 1 under here, which is 3, 1 under there is 4, then under this one is 5.
The way I counted, I was just going like...
You said you did it a different way. Explain it again how you did it.
I counted like 1, 2, 3, 4, 5. I didn't count the ones under.
Now I love that because you knew that they were underneath, and you used a way that you can actually prove that you can actually see. And you know that because in the blocks that are there aren't any gaps or overlaps, right? In the next layer, and then how many in this layer, and how many in this layer, and then add that up, find the sum, see if there's any relationship to the expression. If there's not, keep going, keep being detectives, keep experimenting, all right?
We said 15.
Yeah, we said 15 on the bottom. And I'm going to check back in a couple minutes, okay? So even though it wasn't complete, you were able to use the dimensions to calculate the volume. Which formula did this remind you of? When you work with volume, it makes you learn two different formulaic methods, right? So which method or which formula did this remind you of? Yes, right? So the second part of this where it says explain numbers. Well, you did that, right? You explained how the numbers represented. But for the next part, why did that work? If you look at my explanation, I would work with something like there's two formulaic methods, standard formulaic methods to calculate volume. In order to know how many total cubic units there are, you multiply length times height. Okay, so I would then just take the second step a little further and explain why. Guys, when I'm looking around the room, you guys are close to being done. I should be hearing math conversations. I should be hearing a discussion of potential methods. I should even see people going back to the previous night's homework and making adjustments to their assignment, if now you understand it better. You can also go back to your pre-assessment, look at the true and false statements, and make sense of what we started this lesson with. A lot of you had several errors. Now you can start to make sense of it.
So this is our categories.
Okay, so then there's another 18 here as well, because you're stating that this method is correct. Where are we generating the other 18 from?
Where am I going to put this?
Plus 2 times 27. So let's look at Ms. Slota's model and see what every number represents. We have atoms and we also have what? Factors, which are factors, right? So we also have our model. Ms. Slota also had a model that only had overlaps and
What is that?
gaps. So we're on the same place with her, right? All right, so she had 13 and she labeled it as number of cubes in the model. So let's transfer ourselves to our model. What's the purpose of your 18? What is the 18 representing in your box? Let's get in here, let's count. Where can we find 18? How is 18 helping us?
Oh, I got it.
Okay, what is it that you have?
Okay, then
What is that? How is 18 related
so
to
the
that?
10
How many over here? Marisol, give me it down. What is the counting here? There's 10 here?
And first I explained what each number was for.
Okay.
And 5 is for width, 6 is for length, and 4 is for height. And I thought the 22 represents the cubes in the box.
You, so did you just do that on your own? You just decided to count how many were already in the box? Okay. Okay.
And the 15 represents the cubes only on the first layer of the box.
Okay.
And the 3 represents the next 3 layers, since total height is 4.
Okay.
The 7 represents blocks that are in the next layers. If you count it, you will have 7.
So in these top 3 layers, there were 7 cubes?
Yes.
Okay, perfect.
And at first, I thought the 30 represented the blocks needed to fill the layer, but later in the second question, I put what the volume was.
Uh-huh.
I figured out that the 30 actually represented the base and not the cube that needed.
Wait, so initially, you thought the 30 meant what?
I thought the 30 meant the cubes needed to fill the next layer.
Okay. Now, once you did the work on the bottom, you made the connection how?
I made a connection by saying I did base times, right? And I multiplied 5 times 6, then it was 30.
Okay.
In my head, it was like just a light bulb.
Now, what makes these additional 3 layers? What makes 30 an incorrect response for those next 3 layers? Why wouldn't that work?
Because there's already cubes here, so you would have to subtract it.
Okay, cool. Very, very cool. All right, and then anything else?
Yes, then I did the expression. I actually messed up here also. When I first did the expression, I forgot to subtract the 7.
Okay.
So I got 2 different answers. But then I looked at the expression again and saw minus 7. So I went back to subtracting 7 and the answer was the same.
Okay, now, would you have gotten the same answer if you approached this problem and did the subtraction before you did the multiplication?
No.
Why not?
Because there's a certain order you have to do. It's called pendas.
Okay.
The parentheses first, so I saw those parentheses. There was no exponent, so I saw multiplication next. So I knew that I had multiply first. I got 90, and then the parentheses were still there. So 90 minus 7 equals 80.
Okay.
They all have 22 plus 15 plus 8. 22 plus 15 equals 37, and then 37 plus 83 equals 120.
Okay, cool. So you're officially a volume detective. All right, cool. Very nice work, Matthew. Well, Irving, for now, make your own observations. Don't ask. No, you want to help other people learn. So, Irving, I want you now just to critique it based on how you're interpreting it. And if you think, didn't you mean, then that's what you're going to write on your Post-it. That could be your question, right? You don't have to ask him, leave it there for him, and then he can have time to sort of reflect, and then you guys can have that continuation of the conversation later. Okay?